What's up? I'm Jonathan and welcome to Maker Tales. This video is all about trying to fix this spiral didgeridoo because as you see, there's a great big hole in it. Now, the plan is to try and use photogrammetry, resin 3D printing, and just a dash of Blender to create a patch that's going to fit as perfect as possible. And then from there, we'll see if it works at all. I have no idea what the result of this video is, but let's get straight into it. And on that lovely note, the first thing we obviously need is a photogrammetry. You can see here, I just get straight onto doing a photogrammetry. If you have no idea how to do a photogrammetry, don't worry. I have an entire video that tells you everything you need to know. It's the Photogrammetry Survival Guide. It's linked down in the description or in the cards. The key thing that I did differently here is I just took a lot more extra photos of the actual break itself. With all those photos then taken, I chucked them all into Meshroom and start computing. My first initial point cloud looks exactly what I'm expecting, and from this point I just jump straight into mesh filtering, making sure that I add a little meshing bounding box so that I only have the mesh that I actually want to use. The resulting mesh looks really good, so I plop this all into Blender. When you import a photogrammetry into Blender, sometimes it comes out absolutely massive or tiny. In this case it was less than 2mm. Thankfully I did my entire photogrammetry with my little 3D printed scale guide inside of the photogrammetry, so I can use the 2 points that are inside of the photogrammetry itself so that I know that these 2 points need to be 10 centimeters apart so I can scale everything up to the correct dimensions. After one quick little size check, I was expecting 8.4 and I got 8.41. I knew that I was working with correct dimensions, and now it came to making the patch itself. To start it off, I just play around with some curves, and then I used inside of geometry bevel, I used that to give it some geometry to the actual curve itself. Once I'm happy with how that's looking, I do the same for the inside. Then once I have that done, it's time to get this to do a nice sort of slice boolean cut with it. Now that is something that's a lot harder than it sounds, just due to the sheer number of vertices here. We're working with 1.8 million, so it gets a little bit complicated. So the best thing to do is just to clean up everything that we don't need. So I literally delete everything that isn't the edge of the break itself. And then now that I just have that nice clean edge, I double check that all the actual sort of intersection point of the curve that I've created, as well as the geometry of the photogrammetry, meet properly how I'd expect it, and then I'll be able to get a nice, simple, clean boolean from it. It took a little bit of playing about with it, but by the end of it, I got this result right here. From this point, it was relatively simple. I just chucked it into Cheeto Box, gave it some pretty default supports, added a few extra supports and gave those supports some supports. After about 3.5 hours later, I was greeted with a pretty decent looking part. Once I did my entire resin working workflow, I had this lovely little cured part right here. Now, the moment of truth. Does it fit? Well, first time round, it didn't quite fit, and I realized the main problem here was all to do with my original photogrammetry that I didn't get inside of one little nook and cranny. So that meant that I had to just file away just a teeny tiny little bit, because it was that little bit right there that was stopping the entire thing fitting in perfectly. Well, from this point, you can see that it looks pretty awful. So let's go and do some wet sanding to get this looking as transparent as possible. Now, this is quite a long process, and for me, it took around 50 minutes. Now, I only have about 7,000 grit, so I can't get this to absolutely perfectly transparent. For that, you need about 12,000 or even higher than that, which is pretty crazy. What I did do is gave it a polish with some jeweler's polish, and then from there we get this lovely result right here. I'm sure we can all agree that it's starting to look pretty darn good, but now it's time to stick this in place. I ended up going with some fast curing epoxy, and in the next shot you might think that it's starting to look even better. That's because I did some extra polishing with this little fluffy thing. Actually sticking this in place was pretty straightforward. I just had to make sure that I had everything ready, a little timer as soon as I started mixing, and then I put on the epoxy pretty thick because I wanted to cover up any air gaps that might be there. Now, I only had one chance to put this part in place, and thankfully it went off without a hitch. All I had to do was hold it in place for 5 minutes, and 1 hour later, I get to test it. Enough of all that dramatic nonsense. Let's go ahead and test this out. I honestly have no idea what's about to happen. I hope that it's going to work. I'm pretty sure it's going to work. But if it does work, just excuse me. I haven't played the didgeridoo in maybe 10 years. So bear with me. But let's see. Does it work? Yay! Anyway, I would call that a success. I am so amazed that this works. I'm absolutely astonished at the precision of photogrammetry. I would have never have guessed that photogrammetry, with a little guide, lets you get that precise a fitting. That is incredible, and I love it so much. A huge thank you to my patrons. You guys are absolutely awesome, and it's been great fun going along with the ride of this one, because I did a whole bunch of sharing of this project over on Patreon. And if you're enjoying what I'm making here, and you think I'm worthy of your support, I would love to see you there too. Thank you for watching, keep making, and let the quest continue.